Hello guys, welcome once more to another video in our YouTube channel. So in this video we look at the St. Benedict Catholic Bilingual College second sequence evaluation for the mathematics opposite science. So we are going to begin with the first question, which is on integration, section A. So we are going to solve, maybe in this video we are going to solve question A and question B, and the next video we solve question C. So do well to turn on your notifications so that when the other videos are uploaded you'll be notified to come and watch. Okay, share the video with your friends, subscribe to the channel, like the video and comment. Now, something always happens when you are watching videos that I upload in this format. I mean videos that I basically record my screen and I type out the solutions. Sometimes the video might not be clear, it might be blurred in your device. So always do well to check your YouTube resolution, okay, and you increase the resolution power to maybe 720 or 360 so that you can see the video clearly. It's also advisable to rotate your phone so that the screen, if you're watching it in your mobile phone, it's better to rotate your phone so that the screen put it in full screen. That's what I'm trying to say, so you can actually see. Okay, so basically I've not solved the questions yet. Okay, I've not even reasoned on it, but I believe we are going to run through the paper together. So I'm going to be solving with a student mindset, okay, not a teacher's mindset. So we are basically going to see the various difficulties that even us teachers, when we are faced with problems for the first time, how we analyze, and the difficulties we also face. Okay, but nevertheless, at some points I'll be using a teacher's mindset so that I can go faster, but I'll explain in every I'm going to explain every step detailing. Okay, so we are going to begin with the first question, which is asking us to evaluate the integral from -1 to 0 of 3x plus 1 divided by the square root of x squared plus x plus 1 with respect to x. Okay, now looking at this question, the first thing that comes to my mind as a teacher is that I'm going to complete the square of the denominator, okay, because I can see a square root and then I maybe use a hyperbolic substitution. But now something again comes to my mind. If I differentiate x squared plus x plus 1 in the denominator, I get 2x plus 1, but the numerator is 3x plus 1, so I can separate 3x plus 1 into 2x plus 1 then plus x, and then I see what I can do. Okay, so I'm going to be, let me see what I can do. Integral from -1 to 0. Let's see if you can recall that. So we are doing the integral from -1 to 0 of, we have 3x plus 1 divided by the square root of x squared plus x plus 1 dx. Okay, so this will be equal to, we can write it as the integral, we can write this as 2x plus 1 then plus x. Okay, and writing it in that form, dx, I can now write it again as I can now separate. So I'm going to have 2x plus 1, okay, then plus, that's the x, then plus the same integral but now with x. I don't know if it's going to help us or if it has reduced the workload, but nevertheless that's just what I saw when I saw the integral. Okay, now let us see. The first part is very easy to integrate. If you see, okay, the first part is very easy to integrate because you realize that if you differentiate this, you simply get what is in the numerator. So it helps us with what we are going to substitute, a use substitution. So I'm going to maybe say that this is equal to I1 plus I2. Now let us begin with I1. Our I1, okay, our I1 is equal to this integral, okay, this integral. Now let us see how to solve that integral. You realize that if you let u squared to be equal to x squared plus x plus 1, then what do we have? As we differentiate both sides, 2u du gives us 2x plus 1 dx. So it means that the numerator of that integral is just 2u du. So we can say that our I1 is equal to, now we need to change the limits because you are changing the variable. So when x is equal to -1, our u squared, for example, is equal to -1 squared, 1 plus 1 2 plus 1 3. So our u squared is equal to 3. So u is plus or minus the square root of 3. I'm just going to take plus the square root of 3. I'm going to explain that later. Now when x is equal to 0, our u is equal to 1. That's, we have u squared is equal to 1. It means u is equal to plus or minus 1. So I'm going to take 1. So if I took -3, I will end at -1. Okay, since I've chosen 3, I'm going to end at +1. So that's just basically it. Now the numerator of this integral is 2x dx, which is 2x plus 1 dx, which is 2u du, and the denominator is now the square root of u squared, because what is inside there is u squared. But the square root of u squared is the absolute value of u, but we have chosen a positive interval, so the absolute value of u just becomes u. So this becomes 2 times, I'm just going to copy this and paste, and then I remove this 2 from here. The square root of u squared is u, because u is a positive interval. So this is the same as 2. Now u cancels u, and when you integrate du, you just have u. Okay, and we need to put our limits of integration from the square root of 3 to 1. From the square root of 3 to 1. I think we have made a little error. Okay, I think 1 squared was 1. 1 minus 1 is 0. Okay, 1 minus 1 is 0, because, and then 0 plus 1 is 1. Yeah, 0 plus 1 is 1. So this down here gives us 1. U squared is 1, so u is plus or minus 1. Even the numerator is the same thing. So we are integrating from 1 to 1, so the result is 0. I don't know why such was being given there. In fact, let us see something. Let us try to plot the graph and see, because remember that the integral of a function is just the area under its graph, okay, in the respective bounds. Dx plus 1. Okay, maybe just that first part. Okay, maybe just this first part will give us 0. Yes, just this first part will give us 0, but this second part I'm not sure is going to give us 0. So let's just allow this first part like this, because you are integrating from 1 to 1, you should get 0. Okay, you should get 0. Okay, now let us move on to the second part, which is I2. I2 is equal to this integral. I2 is equal to this integral. Now I'm going to complete the square. X squared plus x plus 1 x plus half all squared. You have x plus half all squared, 1 minus 1 on 3 times the square root of 3 divided by 2 all squared. Okay, so I've completed a square. Guys, please, if you don't know how to complete a square, I think you will have to learn it. Okay, you will have to learn it so that it is your process of integrating. Okay, so this integral simply becomes the integral, the denominator, I just write what I have, x plus half all squared plus the square root of 3 divided by 2 all squared. Okay, now I can now use let me see which substitution can go. Let us say, maybe, can hyperbolic go? Yes, hyperbolic can go. Hyperbolic can go, yes, it can go. Or maybe tangents can go. If maybe I let x to be equal to, no, x plus half to be equal to root 3 divided by 2 tan theta, you realize that if I differentiate both sides, the x will give me root 3 divided by 2 sec squared theta d theta. Now when x is -1, because from here we can get theta, if we change, in fact, let's just do it without changing the limits. Let's just do it indefinitely. So I just have the integral, then later on we find the I2 by now replacing the limits. So the x in the numerator, if you look for x here, okay, we are just going to have root 3 divided by 2 tan theta minus half, that is x. Now I need to divide it by the square root. Now this x plus half all squared is simply root 3 tan theta, root 3 on 2 tan theta all squared. Okay, so you can have something like root 3 on 2 theta all squared tan squared theta, and you just see that in the next term you can just factorize this root 3. Okay, just factorize it out. Now we are left to replace the x. This is the x, just replace it up here. Like I said, forget about the limits for now, it's disturbing. So this is the integral. Now the denominator, you realize that you have a square root. Okay, you have a square root all squared. You realize that this square root outside here just cancels what is here, so you are just left with the square root of 3 divided by 2 at the end of the day. Okay, now tan square theta plus 1 is sec square theta. The numerator, we can factorize half. When we do that, we are going to be left with root 3 minus 1, root 3 tan theta minus 1, then multiply by, there's still another root 3 on 2 again, so I put the root 3 here. Okay, then I can put the on 2 here to have this. Now sec squared theta is theta. Okay, alright, so if we simplify, you realize that root 3 on 2 will cancel with root 3 on 2, so the half will remain. So we have half. The integral sec squared theta cancels with sec squared theta, and what is left inside here is root 3 tan theta minus 1. Okay, so we have root 3 tan theta minus 1 the theta. Now this is a process of integrating. So if we integrate, we have half. Now we can factorize the root 3 and then we integrate tan theta, and we know that if you integrate tan theta, we just get the ln of the absolute value of the cosine of theta. No, negative the ln. Yes, if I can remember well, it's been long. Negative the ln of, yes, this is what we have. It's a standard integral. Now when the half multiplies with negative 1, you have negative half. When you integrate, you have just theta. Okay, then plus a constant of integration. Okay, now what is the value? What's the value of theta? Value of theta is, you see that from here. If I want to get theta, let us simplify. I first want to multiply all through by 2, then I divide by root 3. So this means that 2x plus 1 divided by the square root of 3 is equal to tan theta. So what does it mean? It means that our theta is tan inverse of 2x plus 1 divided by the square root of 3, that is theta. Okay, so it therefore means that that integral is just equal to, now let us begin with, in fact let us rewrite it. Okay, so in the place of theta, I simply put tan inverse 3, I have 2x plus 1 minus, can we even explain it, tan inverse of 2x plus 1 divided by the square root of 3. Alright, so that our integral. I just need to now put the limits of integration back, since I've replaced everything back to x from -1 to 0. Okay, let us fit the upper limit. If I replace 0, I simply have here tan inverse of 1 on root 3. Tan inverse of 1 on root 3. Tan inverse of 1 on root 3. I don't know if it's 30 or it's 60. Scientific. Okay, second function, trigonometry. Second function, tan inverse of 1. Okay, I have to put the angle first. 1 divided by the square root of 3 equal to, hold on, 1 divided by 3 the square root. We have this. Second function, tan inverse is 30. Okay, it's 30 degrees, 30 degrees, 30 degrees. And then cosine of 30, so let me just put here, we have negative root 3 divided by 2. The ln of the absolute value of the cosine, this is still the upper bound. The cosine of 30 is root 3 divided by 2. Yes, absolute value. Okay, minus half. Now tan inverse of 1 divided by root 3 is 30 degrees, which is pi divided by 6. Okay, minus. Now let us fit the lower bound. Okay, the lower bound, we are replacing -1. Here we have tan inverse of -1 on root 3, which is -30, and the cosine of -30 is the same as the cosine of 30. So I still have my -root 3 divided by 2, the ln of the absolute value of root 3 divided by 2, that's the cosine of -30. Cosine is an even function, minus half. Now tan inverse, I have negative pi divided by 6. Okay, now let's subtract the lower bound from the upper bound. This quantity here cancels with this quantity. We have -half times pi divided by 6 minus, now you realize that this just becomes plus, right? You put this minus, so -half times pi divided by 6 minus half times pi divided by 6 is simply the negative pi divided by 6, which is negative pi divided by 6. So that's our response. Remember that the first part of the integral was 0, so when we add 0 to it, we just have this quantity. Okay, so that's basically it, guys. That's basically it. I don't know how we can check our answer. I don't know if this graphing here has integration there. No, there is no integration. There's no integration. Anyways, I wanted to plot, or in fact, let us see if we can use another methodology. Okay, let's not separate. So guys, please, I've maybe made an error when solving. I don't know, because I'm typing directly. I've not solved the equation before, so maybe I've made an error without seeing. Nevertheless, try to identify the error and correct it. Follow the steps. If you find any error, comment in the comment section so that others should also see. But I believe the analysis and the methodology is okay by you all. If you never wanted to actually separate, okay, this what we basically do, that's, let's use that second way and see what we have. We still complete the square. Okay, we still complete the square, but and then we allow the 3 there, so we have 3, we have x plus half all squared plus the square root of 3 divided by 2 all squared. Then we give it 3 and 4, we add this 1 and 4, you have this. Okay, now from here we can still do the very substitution. We do the very substitution, okay, and we simply replace, we look for the value of x. So this integral, let's just do it without involving the bounds. The denominator will still give us root 3 divided by 2 times sec squared theta, and then the numerator we have to take 3. Now what is the value of x? I think our value of x was basically, where is x? I don't know where we had x. X was basically root 3 on 2 tan theta minus half. So here I'm going to put the square root of 3 divided by 2, the tangent of theta minus half, that is x. So this is 3x. Now we need to add 1 to it according to this, and then we multiply everything now with the x, but the x is simply root 3 divided by 2 sec squared theta z theta. So this is it. Now you see that this here, no, let me just write it so that you should not miss steps. So you see that this here cancels with this here, okay, they cancel, and you're left to integrate. We have 3 divided by 2, we have here root 3 tan theta minus 1 and plus 1, okay, z theta. That's what we now have to integrate. So oh no, that this bracket is for everything here. Okay, so this will give us, let us multiply 3 on 2, then we integrate the square root of 3, the tangent of theta. Now we have to multiply 3 on 2, then we add 1 to it. You just going to give us negative half. Okay, just have negative half. There we have negative half, then the theta. So we have 3 divided by 2. If we integrate this, we just have root 3 times, actually negative root 3, right? Since you're integrating tan theta, negative root 3, the limit of the absolute value of the cosine of theta. When you integrate half, you have theta divided by 2. Yes. This 3 divided by 2 actually, look like in this 3 divided by 2 was just for this first term, right? So this half here, if I'm putting 3 on 2 for everything, the half there should not carry the 3 divided by 2. So it should just be kind of the theta. Let me just say minus half the integral of the theta. So here just keep this one like this, minus theta divided by 2 plus a constant of integration. Okay, now you realize that if you want to change our bounds, our theta gave us tan inverse of 2x plus 1. Now you realize that when x is negative 1, theta is negative pi on 6, and when x is 1, theta, when x is 0, theta is pi on 6. So just have from negative pi on 6 to pi on 6. Okay, now you, yes, from negative pi on 6 to pi on 6. Okay, so that's theta. Now you see that the cosine function is basically cosine function is an even function. So even the limit of it is an even function as well, since we have absolute value here. So basically we have integral from negative pi on 6 to pi on 6 to give you 0. Okay, that's this result. Computing it at plus or minus pi on 6, you are going to get 0. Here if you put minus pi on 6, okay, anyways guys, it is basically okay, because if you replace pi on 6 and minus pi on 6 and subtract, this first term will give you 0, because the cosine function of pi on 6 is the same as the cosine of minus pi on 6. So the upper and lower bound in respect to positive pi on 6 and minus pi on 6 is 0 when you subtract. Now the upper bound in respect to pi on 6 will be minus half, okay, minus half times pi on 6 minus Now the lower bound will be the same thing, minus half. This time around is going to be minus pi on 6. Okay, now this just becomes positive half, which now comes back to what we had in the beginning. So basically we are very correct. Okay, thank you guys for watching. I think the video is already, let me see how many minutes it is. It's around 25 minutes already. So guys, I'm going to see you guys in the next video. Okay, maybe in the next video, in fact I think I already did the video, or I already did 2b. Okay, so just check beside this video, you're going to see 2b in this channel. And in the upcoming videos, you can choose between these questions and tell me what to do first. Okay, you can tell me what to do first. Is it 2a? 2a was very complicated. I don't know if it's complicated for you a bit. I saw the trick there, how to develop some functions, though I never even used integration by parts. I did something else, no integration by parts. So I'll be very interested if you can send me your solutions of this question, if you actually succeeded solving it using integration by parts. Okay, send me your solution. I'm going to upload my own methodology which is not related to integration by parts in this channel, so that you see how I reasoned it out. Basically I was reasoning it out using a teacher's mindset. That's why I was able to get it. So because I saw that maybe if I want to perform integration by part, it might be long, you see. So if you use integration by parts, you can send me your solution. I'm going to put my WhatsApp number so you can get to me. When I'm going to upload the solution to this question, you tell me if you prefer my methodology or you prefer integration by parts. Okay, thank you guys for watching, and see you in the next video.